Hello again, and welcome back. What we're going to do in this video is, given the graph of a sinusoid, we're going to try to write its equation. So, with the graph of a sinusoid, there are many things to consider. We need to look at the period of the graph. We need to look at the amplitude. We need to look at the midline to see if there's any vertical shifting. And we have to look at the phase shift. Okay. So these are all crucial aspects that came into play with the equations y equals a sine bx minus c plus d, or y equals a cosine bx minus c plus d. Okay, so each of those letters has a role in this equation. So first thing to notice is maximum value of the graph of the function is 7. In fact, this point has coordinates 5, 7. This point has coordinates 1, 1. Okay, and that means this point here has coordinates 9, 1, and this point here has coordinates 13, 7. So if I look between the maximum points, that has a period of 8. The maximum points happen 8 units apart. The minimum points happen 8 units apart. Any corresponding point is going to happen 8 units apart. So my period is 8. Next thing I notice is, since the maximum value is 7 and the minimum value is 1, we have a midline of y equals 4. Okay, so that's going to help us detect the vertical shift. Now here is where things get a little interesting. Remember that a cosine graph without a phase shift would have a y-intercept either at its maximum point or its minimum point. A sine graph that has not been phase shifted will have a y-intercept at the midline. That is not happening here. We have none of that happening here. In fact, our y-intercept here is 0, 2, not the midline, not the minimum, not the maximum. So that means that this graph has also undergone some sort of a phase shift. So let's see what kind of a shift is required to make it look like a more typical graph. And as I look, it looks like this minimum point was shifted to the right 1 unit. Now we know that if the minimum point was the y-intercept, that's an inverted cosine graph. So I'm going to write down phase shift right 1 unit. And I'm also going to write inverted cosine graph. So I am going to select this one. Okay, the only thing we have yet to figure out is the amplitude. Well, the amplitude, remember, is the vertical distance between the midline and either the minimum or the maximum point. And since the maximum value is 7 and the midline is 4, that means that the amplitude is 3 units. But now remember, that's not necessarily the value of A, because if the graph was inverted, I have to use the negative value of A. If the graph was not inverted, I have to use the positive value of A. So let's just make a list of all of these things that are happening here. So since we decided it's an inverted cosine graph, that means A is equal to -3. Okay, the period is 8. So that means that 2 pi over b is equal to 8. If we saw that for b, so we multiply both sides by b, we divide both sides by 8, we get b equals pi over 4. I know that the phase shift is right 1 unit. Well, that means that c over b is equal to 1. The phase shift formula is c over b, and we know that is equal to 1, which I'm just going to go ahead and solve it for c right away. That means that c is equal to b, but that means that c is equal to pi over 4. Okay, so we have 3 of the 4 letters here. We know that d represents the vertical shift, but at the same time is the midline. So that means that d is equal to 4. So now that we have all of that information in front of us, we can now write the equation of the curve. I'm going to use f of x. A is -3 cosine pi over 4x minus pi over 4. Substituting b is pi over 4 and c is pi over 4, and then d is 4. And there is the equation of our sinusoid.